Hello. So next I am going to tell you how to find the inverse Laplace transform using convolution theorem. So which is very important in our module. So next step is convolution theorem. So first I will give you the theorem of convolution. The theorem says that if L inverse of f of s equal to f of t and L inverse of another function g of s equal to g of t, then L inverse of the product f of s into g of s can be found out using the equation integral 0 to t f of u g of t minus u du, or we can take integral 0 to t f of t minus u g of u du. So this is the theorem. So this is an important method for finding the inverse Laplace transform of certain function. This theorem says that if we have given two functions, suppose we have two functions f of s and g of s, and we know the inverse of f of s and g of s respectively, then we can find out the inverse of the product f of s into g of s easily by doing some integration, integral 0 to t f of u g of t minus u du. So I will give you this theorem. Using this theorem we can find out the inverse of some function. So you will be given some question like this: apply convolution theorem, apply convolution theorem to evaluate inverse of L inverse of s by s square plus a square. So this is our question. So first step is we have to identify two functions like this f of s and g of s. So the given here we have given function as s by s square plus a square the whole square. So first step, suppose we have to take this function f of s is equal to s by s square plus a square, and let us take another function g of s as 1 by s square plus a square. Then s by s square plus a square into 1 by a square plus a square, we will get the given function s by s square plus a square. So first step, we have to identify two functions f of s and g of s. Now the second step is you have to write its inverse correctly. F of s is s by s square plus a square. So f of t is the inverse of this function. What is the inverse of s by s square plus a square? Yes, cos at. Inverse of s by s square plus a square is cos at. And we have another function g of s is equal to 1 by s square plus a square. Now you find out its inverse also. G of t. We know that 1 by s square plus inverse of 1 by s square plus a square is clearly sin at by a. Now, what is the theorem? We have the theorem inverse of f of s into g of s is equal to integral 0 to t f of u g of t minus u du. So that means we have to write the given function f of t in terms of u. Here integrating variable we have to take that f of u. Integrating variable is u. Similarly, I will here f of t equal to cos at. So we can write f of u as f of t equal to cos at. Therefore f of u equal to cos au. Simply replace t by this u. Similarly, g of t is sin at by a. So we can write this g of t minus u as, put instead of t minus u. Here sin a t minus u sin a t minus u divided by a. Now we can apply the theorem. We can apply the results. So by convolution theorem, L inverse of f of s into g of s equal to integral 0 to t f of u g of t minus u du. That is integral 0 to t. What is f of u? F of u is cos au into g of t minus u. G of t minus u we get as 1 by a sin. This we can write as sin of at minus a. Then du. Right. Now we have to integrate this. That is, here 1 by a is constant. Integral 0 to t cos au sin at minus au du. Now how you integrate this? Integral cos a sin b. So there we have to use some equation. I will give you some equation when we come across the product of two function. I have already given. We have results now. We have some result. That is cos a sin b we can write as 1 by 2 of sin a plus b. Sorry, sin a plus b minus sin a minus b. So using this we can write the given product cos au sin au. You have to take this au as a and at minus au as b. So we have 1 by a integral 0 to t cos au sin at minus au. Sin at minus au du. Now using that theorem. What is the theorem? This one, cos a sin b equal to 1 by 2 sin a plus b minus sin a minus b. So here 1 by a 1 by 2 integral 0 to t sin a plus b. A is au and b you have to take this at minus. So sin a plus b, au plus at minus a. So sin at remains minus sin a minus b, au minus at minus plus. So 2au minus at. We will get 2au minus at du. So that is, now integrate this one. 1 by 2a. Integration variable is du. So integral sin at du. With respect, if we integrate with respect to u, then this t is constant. So sin at is constant. Then integral du is u. Then we have to apply the limit 0 to t. 1 by 2a is common for all these two terms. Minus the integral sin 2au minus integral sin is minus cos. So minus cos 2au minus at divided by the derivative of this bracketed term with respect to u, that is 2a. So divided by 2a du. Here also we have to apply the limit 0 to t. Clear? That is 1 by 2a sin at upper limit minus lower limit. So u t minus 0, then minus become plus cos. Here listen here, we have to apply the limit for u only because the integration variable is here u. So cos 280 minus 80, upper limit is cos 280 minus 80, that is cos 80. Cos 80 by 2a minus lower limit. When u equal to 0, we get cos of minus 80. Cos of minus 80 by 2a, that is 1 by 2a t sin 80 plus cos 80 by 2a. Cos of minus theta is cos theta itself, so minus cos 80 by 2a. So these two terms will cancel. These two terms will cancel, similar terms. So we get the answer as t sin 80 divided by 2a. So this is the inverse of the given function using convolution theorem. So what are the steps? First, we have to split the given function as f of s and g of s and find the corresponding inverses f of t and g of t. Then you write down the function f of t as f of u and g of t as g of t minus u and apply the results directly. What is the convolution theorem? In L inverse of f of s into g of s is equal to integral 0 to t f of u g of t minus u du. So you have to by heart these results. Convolution theorem is L inverse of f of s into g of s is equal to integral 0 to t f of u g of t minus u du. Then simply substitute all these. F of u is cos au, then in integration, then we will get the answer as t sin 80 by 2a. I will give you another example also. Next question is, apply convolution theorem. Apply convolution theorem to find the inverse of s square by s square plus a square into s square plus b square. So our question is, apply convolution theorem to find the inverse of s square by s square plus a square into s square plus b square. Here also the given function can be written as the product of two function f of s and g of n. So first step is we have to identify two function f of s and g of s. So let us take f of s is equal to 1 s by s square plus a square. Similarly, we can take another function g of s as s by s square plus b square. Now, what is the second step? We have to identify its inverse. So, inverse of f of s. What is the inverse of s by s square plus a square? Yes, cos 80. Now, we write the inverse of s by s square plus b square. This is also cos bt. Then, next step is we have to write this f of t as f of u. So f of u is cos au. Clear? Then next is g of t minus u. Write g of t as g of t minus u. So we have to change this t. Instead of t, we have to write it as t minus u. So cos b t minus u, that is cos bt minus bu. Cos of bt minus bu. Now the involution theorem, L inverse of f of s by convolution theorem. By convolution theorem, L inverse of f of s into g of s is equal to integral 0 to t f of u g of t minus u du. Now simply substitute this. What is f of u? F of u is 0 to t. F of u is cos au and g of t minus u. G of t minus u is cos bt minus bu du. Okay. Now we can see that in the integral terms, cos a into cos b terms. Okay. So we have to know that result, that cos a cos b. Do you remember that? What is cos a minus cos a into cos b? Yes, cos A, we have cos A into cos B equal to, what is that? 1 by 2 of cos A plus B plus cos A minus B. Okay. So here we have to integrate this. What is that? Cos AU cos BT minus BU. So we can write this as, so L inverse of the product S square by S square plus A square into S square plus B square equal to integral 0 to T 1 by 2 cos A plus B. A is AU. You can take this A as AU, BT minus BU as B. So cos A plus B first. So cos AU plus BT minus BU. Cos AU plus BT minus BU. Clear? Plus cos A minus B. So AU minus BT plus BU du. Then next step, 1 by 2 integral 0 to T. Club these U terms first. This we can write as cos A minus B into U plus BT. Cos AU minus BU can be written as cos A minus B into U plus BT. Next term, cos, now club the U terms, AU plus BU. AU plus BU, that we can written as A plus B into U minus BT. Clear? So du. Okay. Now integrate this. That is 1 by 2 of, what is the integral cos? Integral of cos is sine. So sine A minus BU plus BT divided with the derivative of this term with respect to U. What is the derivative of this bracketed term with respect to U? That is A minus B. This constant is A minus B. Plus derivative of next term, derivative of cos is sine A plus B into U minus BT divided by this A plus B. Here the derivative is A plus B. Now we have to apply the limit 0 to T in both terms. 0 to T. Okay. That is 1 by 2. So 1 by 2, apply the limit, put T, U equal to T, upper limit is T. So listen here also we have to apply the limit for U only. So when this U equal to T, we get sin AT minus BT plus BT. So sin AT remains. So the first step is sin AT by A minus B minus, when U equal, lower limit is here 0. So when U equal to 0, we get sin BT itself. Sin BT divided by A minus B. Then in the next term, similarly we have to put the upper limit and lower limit. When here the upper limit is also T. So when this U equal to T, then we get AT plus BT minus BT. So sin AT remains, BT will cancel. Sin AT divided by A plus B. Then next term, minus, upper limit minus, when U equal to 0, we get sin of minus AT minus sin of, here also when U equal to 0, we get sin of minus BT divided by A plus B. That is 1 by 2 sin AT by A minus B minus sin BT by A minus B plus sin AT by A plus B. This sin of minus theta is sin plus sin theta. So this minus into minus plus sin BT divided by A plus B. Then in the next step, we have to make the common denominator as the product of a minus b into a plus b. What is the product of, here the LCM is a minus b into a plus b. A plus b into a minus b is, we get a square minus b square. So multiplied with this LCM, a square minus b square throughout. So we get here sin at into a plus b minus sin bt into a plus b plus sin at into a minus b plus sin bt into a minus b divided by the product a plus b into a minus b. Taking LCM and simplify these results. Okay, so how we can simplify this? This we can write as which is equal to 1 by 2 of, slowly multiply these terms, a into sin at, this term says a sin at plus b into sin at, b sin at minus a sin bt, next term a sin bt minus b sin bt, then next term a into sin at, minus b into sin at plus a into, next term here a into sin bt minus b into sin bt whole divided by a square minus b square. Now you can see that the similar terms will cancel. Listen here, b sin at, here b sin at minus b sin at will cancel. Then minus a sin bt plus a sin bt will cancel. So remaining terms is a sin at plus a sin at. So 2 times a sin at will remain. Similarly, minus b sin bt minus sin bt. So 2 times minus b sin bt will remain, divided by the denominator a square minus b square. Yeah. So the answer, this 2 is also will cancel. So the answer we get as finally sin a sin at minus b sin bt divided by a square minus b square. So which is the inverse of the given function. So this is the step we have used in convolution theorem. So in most of the problems we have to use the product term. I will give you that results. Okay, the results we have applied here. I hope I have already given in our classes, college days, that formulas are sin a. The results we have to use in this section. Majority of the problem we have to use these results. So you have to by heart this one. Sin a cos b we can written as 1 by 2 of sin a plus b plus sin a minus b. When we have cos a sin b, then we have to use the equation 1 by 2 of sin a plus b minus sin a minus b. Similarly, when we come across cos a cos b, that we can written as 1 by 2 of cos a plus b plus cos a minus b, then sin a sin b. If we have the integrand sin a sin b, then we have to write the equation as cos a minus b minus cos a plus b. So in majority of the convolution theorem problems, we have to use one of these formulas and do the given problem as given. Okay, so I hope you understand this thoroughly. Thank you.